Tiende pamoja ni mtima umo. 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 Tiende pamoja ni mtima umo.
Hello, welcome to MTN Teleschool. My name is Samanenga, a teacher of mathematics from the Casa Boys Boarding Secondary School. We are here again to help you prepare for your final exams. After the announcement of the indefinite closure of schools, we felt we should reach you out and prepare you for the final exams. I'm going to take you through Mathematics Paper 2, 2019, and I will start with the first question, that is question number 1. So question number 1 is based on matrices, and it states, given that matrix A equals 6, x, 2, and 3, then first part of the question states, find the value of x for which the determinant of A is 36. So we want to find the value of x. The determinant of this matrix given is 36. So how do we find the determinant? We know that determinant is given by that. Then we have the diagonal, the major diagonal, and we are going to subtract the product of the minor diagonal. So the major diagonal is 6 by 3. Then minus, the minor diagonal, which is 2 times x. And when you multiply 6 times 3, you get 18. But we've already been told in the question that the determinant of this matrix is 36. So where there is that determinant symbol, we're going to put 36. Then minus 2 times x, we have our 2x there. All right. So now we are going to simplify that equation that has been formed out of the product of the minor diagonal and the major diagonal. So we're going to have 36. When we transpose 18 to the other side, we are going to have minus 18 equals negative 2x, right? So when we subtract 18 from 36, we have 18 equals negative 2x. Dividing both sides by negative 2 gives us negative 2, also negative 2 here, because we've been asked to find the value of x, and the value of x equals negative 9, right? So we have answered the first part of the question, which requires us to find the value of x. So part 1, the value of x is 9. We move on to part 2 of the same question, and the part 2 states we need to find the inverse of A. The inverse of matrix A, we know again that matrix A is given by A equals 6. Now we know that where there is x is negative 9, and then 2 and 3, we substitute. In order for us to find the inverse of matrix A, we know that inverse is denoted by that, a to the power negative 1. We don't read a power negative 1, but we say A inverse. So as it is, you might say a power negative 1, but we don't read as a power negative 1. We simply say A inverse. So A inverse, first of all, we've ascertained already that the determinant of matrix A is 36. So we'll find the reciprocal of 36, which is 1 over 36, and multiply this determinant by the adjoint of the matrix A, which is 6, negative 9, 2, and 3. But then the adjoint of this matrix, well, watch, we're going to maintain the major diagonal. We're going to swap them. The elements, the major diagonal will have 3 and then 6 here. Then the elements in the minor diagonal will remain the same, except we are going to multiply throughout by a negative number. And so if we multiply throughout by a negative number elements in the minor diagonal, we are going to have this negative 9 will now become 9, and this 2 will become negative 2 after the multiplication. Right, I hope you're following closely. Thereafter then, we are going to multiply the the reciprocal of the determinant, which is 1 over 36, multiplying it with all the elements in the adjoint of the matrix A. So we're saying 1 over 36 multiplied by 3, multiplied by 9, multiplied by negative 2, multiplied by 6. And if we do that, we'll have 3 over 36. This also multiplied by 9 over 36. And again, we are going to have negative 2 over 36. Also 6 over what? 36. This is the matrix that we are going to obtain. Right. Now, we are going to simplify this matrix so that we do not have to leave it in that form. And when we simplify this, we are going to have 3 there, 1, and 3 there, 1, and there. So we are going to have 1 over 12, and 9 there is 1, and 9 into 36 is 4. So we are going to have 1 over 4. The negative 2 there is 2 into 2, 1, 2 into 36, we are going to have 18. So we'll have 1 over 18, and bearing in mind that that's a negative. Then 6 there, 1, and 6 into 36 give us 1 over 6. And so this is the inverse of the matrix given. You need not to stress when it comes to answering questions on matrices. When they ask you about the determinant of any given matrix, what you need to have in mind is that determinant is simply, you have to understand what, you have to understand what is the major diagonal, the product of the major diagonal, multiplied by the, you subtract the product of the minor diagonal, then the answer that you find is the determinant. Right, so now we are going to move on to another question, and question 2. Question 1b is based on is on probability, and it states a box contains 4 red pens and 5 green pens. A pen is picked at random from the box without replacement, and a second pen is then picked. The first part of the question states, draw a tree diagram to illustrate the outcomes. So what is going to help us draw the tree diagram? The information given in the question, we need to understand that, we need to understand that the total number of pens given equals 4 plus 9, of which 4 are red pens. 4 plus 5, that gives us 9. 4 are red pens, and 5 are green pens. Okay, making the sample space of 9 pens which are given. Now the first question, before we go to the first question, we need to understand what we are talking about. It states a pen is picked at random from the box without replacement. Meaning, if we do a picking from where the pens have been put, once we pick one pen, we are not putting it back. And that is the reason why we have been asked to demonstrate or to illustrate this using the tree diagram. So how is the tree diagram going to be like? Okay, so we are going to say, excuse me, using our tree diagram, okay, let me say, so that we create more space here, we have this situation, the first pick, we have the red pen and also the green pens. So if we are to pick the red pen, the probability of picking the red pens, we know that we have 4. Out of how many pens? We have 9 pens altogether. So we shall say 4 over 9, That would be the first pick. And if we are to pick a green pen, we know the number of green pens. We've been told in the question to say there are 5 green pens, so it will be 5 over the total number of pens, that is 9. That will be the first pick. Second pick, how are we going to move? So we're going to have another tree drawn like that. Also another tree drawn like that. So we have the red pick there, pen, and green, red, and what? Green. Now, the question states, after the first pick, the pen is not replaced, meaning the sample space is going to be affected. It will not remain the same. In the first pick, the sample space is out of 9. In the second piece, the sample space will reduce by 1 because we had already picked in the first instance. So how is it going to be? If we are to pick a red pen again, we are going to have that. We're going to have 3 over 8. The sample space has reduced because the first pen has not been replaced from where it has been picked from. The same goes to if we are to pick green in our second picking, we're going to have 5 over what? Over 8. And if we move on, again, if we are to pick the red pen there, we are going to have 4 over 8. And finally, if we are to pick the green also there, we're going to have again 4 over 8. I hope that settles well with you out there. And so, what is the question asking us to do? The question is simply asking us to illustrate this using the tree, using the tree diagram. We've drawn the tree diagram. Now, maybe for the sake of illustrating further, we know that if we are to pick red, red is going to be red here. Then red and green, we're going to have red and green here. Then we also have green and red, so we are having green and red here. We also have green here. Okay, that is an illustration. We've just been asked to illustrate that using the tree diagram. So we don't need to spend much time and panicking a lot about how am I going to illustrate and all that stuff. We need that to understand that there was a first pick, there was also the second pick. Now, what is question part 2 saying? Question part 2 says, what is the probability of red? So that one is not going to be our area of concern. The second instance, we have red-green, and this will attract our attention because there is 1 red pen and 1 green pen. The third pick, there is green and red. It is also our point of interest because we have 1 green pen, we also have 1 red pen. Right. So now, how are we going to move? We are expected to find the probability of picking 1 red pen and the probability of picking 1 green pen. Right. That is what's expected of us. So then, what are we going to do? What is the probability of red, green? In the first pick, the probability of red, green, we are going to add it to the probability of green and red. But then we need to understand what is red-green. Here we are multiplying the probability of picking a red in the first instance and the probability of picking a green in the first instance. So when we go to our illustration, the probability of picking a red is 4 over 9, and that of picking a green is 5 over 8. So we are going to say 4 over 9 multiplied by 5 over 8, 5 over 8, then we add it to the probability of green and red. So what is the probability of green and red? green is the first peak is 5 over 9. So we're going to say 5 over 9 plus red, which is 4 over 8. I mean, multiplied by 4 over 8, sorry. 4 over 8. So we can do better there by doing away with this. Then we multiply this. Right. Okay, fine. Now, if we multiply that, 4 by 5, we are going to have 20. Everything over 9 by 8, that is 72. Then plus 5 by 4, there again we're going to have 20. And we are going to have 9 by 8, also 72. Right. Hope you're following closely there. And now we are going to do some simple calculations, some simple mathematics. Simply, these are numerical fractions. And you remember grade 5 work, there we're supposed to find the common denominator. And the common denominator in this case is our 72. Then 72 into 72, we have 1 multiplied by 20 there. The numerator, we have 20. Then 72 into 72, again, we have 1 multiplied by 20 there, we have a 20. And so adding or simplifying this, we have 40 over 72. And if we further simplify this, we are going to see that we are going to have 5 over 9. And this is the probability of picking one red pen and the probability of picking one green pen. So how have we arrived at this? We have reduced this. We said 9 into 40. We have 80. We reduced this 40 and 72 by finding a number that can go into both 40 and 72 to reduce it to this answer that we have gotten. Right. So now we move on. We are done about that question on probability. We want to move on to the next question, which is question number 2, paper 2, 2019. Question number 2A states simplify. Okay, question number 2A states simplify 6x squared minus 24 everything over x minus 2. When you look at the given mathematical expression here, which we've been asked to simplify, it is clear that the denominator of this given expression is a quadratic expression, and the numerator is a linear expression. So what are we going to do in order for us to simplify this expression as we have been asked to do? First of all, we need to factorize the numerator of the given expression. Factorize the numerator of the given expression. So if we factorize the numerator of the given expression, we are going to have, which is common, using the common factor. And the common factor in 6x squared minus 24, we can vividly see there that the common factor is 6. And so if we factorize 6, we have x squared minus, and 6 into 24 gives us 4. Then we close the brackets, everything over x minus 2. Right. Now, we can see that we still have the numerator, which is still complex. And since the numerator is still complex, we need to simplify it further so that we can have it easy to work it out here and there. And now, when you look at the numerator, we have got two factors, that is 6 and x squared minus 4. X squared minus 4 is a difference of 2 squares. We can factorize this by a difference of 2 squares. I hope you remember the factorization by a difference of 2 squares. What it means, factorize, we're going to factorize by difference of 2 squares. Okay. Difference of 2 squares. How is it 2 squares? Are we able to see the 2 squares there? Yes, we should be able to see the 2 squares. So this means that we have 6 and x squared minus 2 squared. That's why we're calling it a difference of two squares. Okay? Everything over x minus 2. Now, this numerator can further be split into two factors because we have x squared, meaning we have 2x, and 2 squared, meaning we have two 2's. Now we are going to split the x, 1 in the first bracket, another x there, another 2 here, another 2 here. Since we are factorizing by difference of two squares, one should be, we are going to use the operation of addition and the other one as subtraction. The order may not necessarily be, it may not be necessary. We can even start with x minus 2 and x plus 2, or x plus 2, x minus 2. The order does not matter. Now we can say everything over x minus 2. Right. So now you can see clearly there that we have made our work very simple and we can easily simplify that given expression. How are we going to simplify it? We are able to see the two factors that are being multiplied. All the three factors in the numerator are multiplying. So we are at liberty to eliminate, or by cancelling or by dividing. X minus 2 can go into this factor x minus 2. We can happily do that without having a lot of difficulties. And so once we divide x minus 2, which is 1 here, and x minus 2, which is 1 there, we are going to remain with the factor 6x plus 2 as our simplified expression. So this is an answer. So once again, when you've been given a mathematical expression to simplify, where one is a quadratic expression and the other one is a linear expression, first follow the steps that I've explained. First simplify the quadratic expression, which is a numerator. If it's a denominator, do the same. First factorize it, make it simple. If it's a factorization by difference of two squares, follow the steps and then reach to the final stage that I'd reached to find the given answer. Right, so I hope you are finding it interesting here to follow the revision of the 2019 paper 2 paper, which was written last year by our grade 12, and very soon people will be sitting for the General Certificate of Education this year, and by the end of the year, those who are in grade 12 will also be able to sit for their school certificate in mathematics. Please, you don't need to stress, you just have to understand that mathematics is made simple with MTN Teleschool, and we are here to help you in the comfort of your home to revise and prepare adequately for your final exams. Right, we move on to our next question, which is question part 2B. And part 2B is a question on geometrical progression. This topic is on arithmetic progression and geometric progression. But in this context, the question is based on geometric expression or geometric progression. And the question reads, given the geometric progression, we have the geometric progression 4, 8, 16, and it keeps on going like that. There they are saying find the geometric mean of 256, 256, and 256 and 1024. What do they mean when they say find the geometrical mean between 256 and 1024? Okay, let's say this 256 is our A, and there is need for another number which is between 256 and 1024. That's the number. What number is in between 256 and 1024? Let's say let that number be B, and then 1024, we know we can say this is our C. So since we've been given A and C already, our main interest is to find the number that is in between 256 and 1024, which they are calling the geometric mean. But how then simply given by the formula B equals the square root of AC. Since we've already been given A and C, we're simply going to substitute A and C in the square root sign and simply simplify the given expression to find the geometric mean. Right, so let's go ahead and substitute these given terms. So the first term is 256, which we are multiplying to 1024. Here also you need to understand that 256 times 1024 means square root of 256 times the square root of 1024. This is the same. So you can still split and find it easy, because when you say 256 times 1024, you end up having a very big number that would be very confusing to find the square root. So you can split the given terms in the square root sign, because we are multiplying them and all of them are in the square root sign. That's why we're saying this 256 times 1024 can be split the way I've written them here. Okay, so now, what's the square root of 256? If you punch your calculator, paper 2, you're allowed to use your calculator, so you don't need to stress much. You can use your calculator to find the square root of 256, and the square root of 256 gives me 16. We multiply it by going to the calculator again, and then finding the square root of 1024. This is going to give me what? 32. Right, and if we multiply 16 times 32, we are going to have 512. And therefore, we can say the geometric mean in that question is going to be, we're going to say, therefore, the geometric mean is 512. Right. So, before we go on break, we are going to look at another question so that we can have a short break of 2 minutes or so, and then we'll move on to another question. But before going on break, let's look at the second part of this question. The second part of this question states, find the 11th term of the given geometric expression. The 11th term of the given geometric expression, this, we need to know that to find the 11th term of the geometric expression, we're going to use the formula Tn equals A R n minus 1, where A is the first term and R first term, and R is the common ratio. In the geometric progression, we have the common ratio and not the common difference, which is the arithmetic progression. And then n stands for the number of terms. So that is what you need to know. In order for us to find the 11th term, we need to bear in mind of that given formula. So now we can simply substitute from the given formula in order for us to find the 11th term. So what is our A according to the given geometric progression? Our A is 4. What is our common ratio? Our common ratio, we need to know that this is simply we divide the second term divided by the first term, or the third term divided by the second term. So in this case, we have, let me take you back a little bit. We have the first term is 4, the second term is 8, and the third term is 16. So in order for us to find the common ratio, we'll say the second term divided by the first term, or you can say the third term divided by the second term. Whichever way you do it, you still find the same answer. In my case, I'm going to use the second term and the first term. So I'm going to have 8 over 4, and when I reduce or simplify that, my common ratio is going to be R equals 2. Now that I've got my common ratio and the term that is needed n there is 11, then I can confidently substitute in the formula, which is Tn equals A Rn minus 1. And where there is n, I'm going to replace it by the 11th term that has been mentioned. Where there is A, I'm going to replace it by 4. And my common ratio is 2. Then n is 11 minus 1. Okay, right. I hope you're able to follow that. And if we further simplify that, we're going to have 10 term 11 equals, now here we're supposed to be careful. We are going first to say 4, then 2 to the power 10. Then 2 to the power 10, you multiply it with 4. You're going to say 4 times 2 power 10 is not 2 times 10, it's 2 multiplying 2 by itself 10 times. That mistake should not be made. So we have our 4 here. Then if we multiply 2 by itself 10 times, we are going to have 1024. And if we multiply 4 by 1024, finally we are going to have our answer, which is 4096 as the 11th term. There we go. So you don't need to have a lot of problems. So before we go on break, let's just finish the last part on this question, which is the sum of the first 11 terms, okay? How are we going to find the sum of the first 11 terms? The sum of the geometric progression is given by the formula A, then R, n minus 1, everything over R minus 1. You need to know that. And already they're saying the sum of the first 11 terms. So again here, n is 11, A is the first term, R we've already found, which was 2, and we just need to replace in that formula. So we're going to say the sum of the 11th term equals 4 there, then our common ratio is 2, and then we are still raising it to power 11, which is the 11th term that we've been given, minus 1, everything over our common ratio 2 minus 1. And when we simplify this, we are going to have 4 and 2 to the power 11, we are going to have 2048 minus 1, everything over 1, which is just a straightforward thing there. I think you're able to follow. Then from there, when we simplify further, this is our sum of the 11th, the sum of the first 11 terms. So when we simplify further, we're going to have 4 over 2048 minus 1. This is how we're going to have it. Then from there, you simply simplify it by saying 4 and 2048 minus 1, that is 2047. And when you multiply 4 by 2047, you are going to obtain 8188. So the sum of the first 11 terms will be 8188. There you go. So you don't need to stress to answer questions on geometrical progression. The answers have already been given. But please, my caution is don't just memorize question. You need to understand what you're expected to do, and then you can apply the same concepts in any question which you are going to be asked. For now, we are going to go on break, but please don't go away. Remember to tag your friends and family to MTN Teleschool so that they can also be part and parcel of this revision exercise. Catch you later in a few minutes' time.
Okay, let me know how it goes.
I will. I need to go now.
And don't forget to check up on your brother.
Ziba mami, I will. I really need to go. Nizachedwa.
And also wish your dad a happy birthday.
Bye. Ish, my mom. She never stops talking. But I'm not complaining because I love our conversations. And MTN's 777 Just For You makes life and communication so much easier. Especially for a student like me, cause sinisebenza just yet. So, with 777 Just For You, I get special discounted data and voice bundles that allow me to do my schoolwork with ease and keep up with the latest trends online. I get to call my family and friends, plus there's also a gift folder. To cut the long story short, I talk more and browse longer. That's my mom. I better video call my dad and brother before class. MTN gives you so much more with 777 just for you. Enjoy amazing day and night bundles, super fast 4G data bundles, Loco Nilaka, and more. Plus, you also get a special gift from us. Simply dial *777# and select an offer of your choice. Sekelela, we are on your side.
MTN.
Hello, welcome to MTN Teleschool. Welcome back. My name is Anton Samanenga, a teacher of mathematics from the Casa Boys Boarding Secondary School. I'm going to take you through paper 2, and it's a continuation from where we ended. Now we straight go to question number 3. Right, so question 3a states solve p squared minus p equals 4, giving your answers correct to 2 decimal places. And when you look at that type of an equation that is given, it's a quadratic equation. And there are many ways in which a quadratic equation can be solved. 1 is by factorization, 2 by complete of square method, 3 using the quadratic formula. But in this case, you look at the number of marks given, 5 marks. It means you cannot solve it by factorization because it's not factorable. So you can either solve it by difference of 2 squares, or you can either solve it by complete of square method, or you can either solve it by the quadratic formula. In this case, we are going to solve this question by the quadratic formula. And the quadratic formula is given by x equals negative b plus or minus square root of 4b squared minus 4ac, everything over 2a. I'm emphasizing everything over 2a, and not x equals negative b plus or minus square root of b squared minus 4ac, then the division line ends there. This is not the correct formula. And once you use this formula in your final exam, you'll be penalized for not using the correct formula. What's the difference? The difference is the division line. This division line ends at the beginning of the square root sign. The division line in the first place ends at where the equal sign starts. Now, when we look at the question given, p squared minus p equals 4, the variable in that question is p. And we shall modify a little bit our formula. Instead of x, we are going to use p. So our formula will be p equals negative b plus or minus square root of b squared minus 4ac, everything over 2a. Right. Now, in that given quadratic equation, we can, let me write it here again. We have p squared minus p, then we transpose this 4 to the other side. We have minus 4 equals 0. And so the coefficient of p squared, the number that is in front of p squared here, since there isn't any number, it means the coefficient is 1. And when you go to the second term, the number that is in front of this p is 1. And we have the constant, which is 4 there. What does that mean? This is our a, this is our b, and this is our c. Right. So now what are we going to say? A from the given formula is 1, and b from the given formula, from the given equation is negative 1. Be careful there. And c is negative 4. Having done that, you simply now substitute the values of a, b, and c in the given quadratic equation. So the given quadratic equation or formula is p equals negative. What is my b? My b is negative 1, right? So I'm going to write it as it is. I shouldn't be disturbed or confused because of the negative sign that I'm already seeing there. I have to lift the value of b with the sign itself without disturbing it. Okay, a negative 1 plus or minus square root of what is my b? Negative 1 all squared minus 4. Then what is my a? That is 1. And what is my c? That is negative 4. Everything, I'm emphasizing on the division line, everything over 2a. And what is my a? That is 1. Right. So now, having done that, we can now just do our simple simplification of the given values in that formula. So when we multiply negative 1 and negative 1 here, we are going to have 1 plus or minus the square root of, when I simplify what is in the bracket there, I'll end up having negative, not negative 1, I'll have 1. Sorry, let me just make it very clear for you. So I'm going to, if negative 1 is multiplied by itself, I'm going to have 1 squared, and then 4 times 4. I'm saying 4 times 4. I'm going to have 16. Let's remove this because we have multiplied it by itself twice. Then I've said 4 times 4 gives us 16. But now there's also 16 times this one here is still 16. Now let's deal with the variable with the operation. Negative times negative here gives me positive, which is a plus sign there. That is also another common mistake which pupils out there, candidates in the final exam, make most of the times, because they just carry this negative sign with them up to the end of the day. But one comforting thing that you should be sure of is that at this level, you will never have the square root of a negative number. Once you work out a certain quadratic equation that is giving you a negative number in the square root sign, just know that there is a mistake that you have done. Go back, revisit your work, see how best you can do your simplification to ensure that you obtain a positive number in the square root sign. So 2 times 1 there gives us 2, so everything is over 2. Now you're going to have 1 plus or minus, then square root of 17, everything over 2. Right. So this means that 1 plus square root of 17, everything over 2, or P equals, because that's the value we are looking for, 1 minus square root of 17, everything over 2. Because it's a quadratic equation, we are going to have two values, because the highest power to which the variable in the given equation is raised to is 2. And that power 2 tells that we are going to find two solutions. Okay, so when we find the square root of that number, we are going to multiply, and we say 1 plus the square root of 17, then divided by 2, we are going to have P equals 2.56, or P equals negative 1.56 as our answers. This is after you have done all your work on your calculator. You can say 1 times square root of 17, you press equals, then divided by 2, you are going to find this. But the caution was given at the beginning of the question, correct to 2 decimal places. And that is the reason why we have left our answers to 2.56, or P equals negative 1.56. There we go. So we are done on this question. We move on to the next question. Question part B, 3B. Question 3B states we have the Venn diagram there. I'm sure you're able to see the Venn diagram. And in the question, they are asking us to, I'll read through. The Venn diagram below shows the number of elements in set A, B, and C. And they're asking us to find X such that such that the number of elements in B equals to the number of elements in B union C or complement. Now, let me try to spend some time explaining something here, right? We have 3 sets, and I hope you're seeing that. We have the universal set, we have set A, we have set B, and we have set C, right? And we have element 7 here, we have 8 here, and then we have x minus 4. We also have our 5 here, and 2y, and then 10 is not found in all the 3 sets. They are asking us to find the value of x such that the number of elements in B is equal to the number of elements in B union C complement. So we are saying number of elements in B is equal to number of elements in B union C or complement, right? So what are the number of elements in B? Our set B is this whole set B, right? So we are going to equate the number of elements in set B to the number of elements in set B union C complement. B union C complement, we are simply interested in looking at the number of elements that are not found in set B and C, but they may be found in set A or the universal set. So what are the number of elements in B? We have number of elements in B, we have 8 plus x minus 4 plus 5. Then we equate to the number of elements in B union C complement or complement, meaning that those elements that are not found in B or C, but they are found either in A or in the universal set. So what are these elements? We can find 7 and also 10. This 10 and the 7 are not part of B and C. So when we simplify here, we are going to have x plus 9 equals 7 plus 10, that gives us 17. I hope you are able to see how we have simplified this. We have added together the like terms, 8 minus 4 plus 5, we are going to get that. So when we simplify like that, then we are going to transpose this 9 to the other side. We are going to have x equals 17 minus 9, and then our x is going to be 8. Right. So we have found the value of x as we've been asked in the question. Right. So we continue with question part 3b, part 2, where we've been asked to find the value of y such that number of elements in C equals to number of elements in set A. When we get back to the diagram here, you're able to see that what we are interested in is number of elements in C. We equate them to the number of elements in set A. Okay, and when you look at the number of elements in set C, we say number of elements in C equals number of elements in A. And number of elements in C is 5 plus 2y, as you can see in the diagram. Then you equate it to the number of elements in A, which is 7 plus 8. And here now, we are going simply to collect the like terms and find the value of y as we have been asked. So we have 2y equals 7 plus 8, and we transpose this 5 to the other side. We are going to have minus 5. I discourage my pupils to say it jumps the equal sign or it crosses the equal sign. we simply say it's transposed, or we add the additive inverse of 5 to both sides, and then it will eliminate itself. So the idea of jumping, crossing over to the other side, that was elementary, a way of putting things. But at this level, you need to be mathematical enough by understanding what we are doing. So we have now 2y equals, when we say 7 plus 8, you have 15, and 15 minus 5, you have a 10, and dividing both sides by 2, you have y equals 10. So the value of y, as asked in the question, is simply, 5. So we can do a good job here by saying 5. Good. Happy. I guess you are happy to see that. Right? So now we are going to move on to another question that is part 3. We need to find the number of elements in the universal set. That symbol stands for the universal set. So meaning, having found the values of x, having found the value of y, then we can add all the elements in the universal set in the given diagram. So what are these elements? We have 7 plus 8 plus 10. I'm sure you're able to follow from the diagram. Plus, then since we have found the value of x, we'll say 8 minus 4, then plus 5 plus 2. Okay? Y is 5. So we are multiplying there. We're going to replace the value of y by 5 like that. Okay, hope that makes you happy. Then we are going to have 7 plus 8 after simplifying, plus 10, plus 4, plus 5, plus 10. Just making it very simple for you to follow. Then from there, once we add everything here, we are going to have 44. So meaning the number of elements in the universal set is 44. Let's look at the last part of this question, which is part 4, question 3b, part 4. The number of elements in set B complement. What do they mean by saying number of elements in B complement? Number of elements in B complement is simply, if I take you back to the diagram here, this is my B. This is B. I hope you're able to see the colors nicely there. This is B. So when they say B complement, we are referring to elements of the sets, elements that are not found in set B. They are completely outside this set B. So they can either be found in C and A, or even in the universal set. That is what we mean. So what are these elements? Okay, let's get back now to these elements. We can identify them as 2y and 10 and 7. So the number of elements in the set negative, number of elements in B complement now therefore gives us, we're going to say equals 7, 7 plus 10 plus 2, we are multiplying with 5. When we simplify this, we're going to have 7 plus 10 plus 10, and 7 plus 10 plus 10 gives us 27 as the number of elements in the set, in the given set B complement. Right, so now we move on. I'm sure you are following. Please remember to tag your friends, families, so that they can also be part and parcel of this revision exercise. We are going now to look at the next question, which is question 4. Question 4a states express 5 over 2x minus 4 minus 4 over 3x plus 5 as a single fraction. What type of fractions are these? These are simply algebraic fractions. The same concept which was used for numeric fractions in primary is the same concept we are applying here. I want to give you an example. For example, if we've been given 1 over 2 plus, or let's say minus 3, okay, 1 over 4 minus 1 over 4. What could be how are we going to find this? As numerical fractions, we're able to find the common denominator. What's the common denominator of 2 and 4? We're able to say 4, and we are very happy. 2 into 4, 2. Multiplied by 1, we are able to say 2. Plus 4 into 4, 1. Multiplied by 1, you have 1 there. And then 2 plus 1, you get 3 over 4. And we are going back home very happy because we did a numerical fraction that way. The same concept that was used, the same concept used on numerical fractions is the same concept that we use on algebraic fractions. So we have the question 5. We have 5 over 2x minus 4 minus 4, everything over 3x plus 5, right? What will be our common denominator? And that's where most of the pupils get confused in the exam or the candidates. We have 2x minus 4 and 3x plus 5. This will form the common denominator. And so we are going to say 2x minus 4, or brackets, 3x plus 5. Then now we can divide the common denominator, the denominator of the first fraction into the common denominator. So meaning this is being divided by that. It goes in 1, and 1, you remain with this factor. This factor times 5. So to make it easy, I'm going to say 5 times 3x plus 5 minus. Now we are dealing with this denominator. So 3x plus 5, when it goes into 3x plus 5, you remain with 2x minus 4. So we're going to say minus 4, then 2x minus 4, like that. And from there, you just simply expand the brackets and simplify to its lowest term as we have been taught. So 5 times 3x, I'm going to have 15x and plus 25, 5 times 5, okay? Now we need to be careful there. We're saying 4 times 2x, I'll have my negative 8x. Watch out for the signs there, this and this sign. Let us not rush into just writing them the way they are. Because if we do so, we'll end up losing the 3 marks that has been given or allocated to this question. So I'm going to be smart here by saying 4, this 4 multiplied by this 4, I'm going to get 16 here. Then this negative multiplied by this negative, it gives me a positive sign. Common mistakes that most candidates make out there when they are working out algebraic equations of this nature. Then we don't forget our common denominator, which is 2x minus 4 and 3x plus 5, right? Okay, and we now simplify. Simplifying this will simply give us 15x minus 8x, then plus 25 plus 16, everything over 2x minus 4, then 3x plus 5, then everything again, when we simplify this, we're going to have 7x plus 41, everything over 2x minus 4, 3x plus 5. And this is our final answer. We have expressed that fraction as a single fraction. Let's move on to, question 4b. Question 4b is based on computer studies. And this component has been introduced. If you start from question papers in 2016 going down up to where we are now, this question has become compulsory. All of you are expected to answer this question, and that's why it comes in section A in paper 2, where you don't need to choose. And so I would like to ask you to get or familiarize yourself with these types of questions. There are two ways in which they are asked. Either they will give you a pseudocode, or they'll give you the flowchart to come up with a pseudocode. In this case, they have given us a pseudocode and we need to come up with a flowchart. So the question reads, the program below is given in the form of a pseudocode. Then there's begin, enter length, 0, then display error message and re-enter positive length. Then else enter height. If height is less than 0, then you have a display of the error message and you re-enter the positive height. There, else the volume, which is given by 1/3 times 1/3 times L times L times H, and end if that is what you are desiring. So then how are we going to come up with a flowchart from the given pseudocode? So it states begin. So we know that the symbol that we use for begin is this. It's an oval-shaped symbol. We are going to say begin. Then we move on to, it's not a rectangle, but it's a parallel type of a shape. And then we say enter, according to the instruction that we have been given, the length. Then we go to the decision-making box there, which is also given by this, because they are saying if you enter length, then display error message and re-enter positive length. So you go into the decision, is length less than 0? If it is less than 0, our decision box is going to be like this, is length less than 0. Then what are we going to do? We are coming from here, and we need to make a decision. We need to display something here. So a display has to be made. So we are saying display error message at this point. Okay, error message. Then you put it into this shape. I hope you're able to follow nicely there. Okay, right. Then we move on. What are they saying? If the decision now is made, you enter H. Enter H. And then you are going to have this situation. Enter H. And you still continue going because we're supposed to make a decision again. After entering H, if H is less than 0, make a decision. And we are going to make a decision. We have entered H. Is H less than 0? Here we are saying no. And then the decision is going to be made here is H less than 0. If not, what action are we going to make? We are going to progress by saying yes. Then a display has to be made. We are going to say display error message. You display the error message and you re-enter the positive height. Re-enter height, the positive height, like that. So if you do that, then you've made a decision. What are we going to say? They are saying else the volume is given by 1/3 multiplied by L, and by H. So we are now going to bring in the volume part, which is volume given by 1/3 multiplied by L, multiplied by L, and multiplied by the what? The H. Having done that now, so you can also see that here is corresponding to that because we are making a decision there, and that's why we say, is h less than 0? Yes, then we are going to display the error message, and we enter the positive height, like I've explained. Then from there, you simply go straight to display the volume, which you've now found as the answer. Now, when the volume is displayed, what is our next step? You've simply ended the whole process. And that's how simply you are expected to work on this question. Right, so we move on to question number 6. We go to question number 6 of the same paper. Question number 6 is based on vectors. In the diagram below, OB, that is what I want you to take note. OB, vector OB equals 4OA, and vector AC equals 5AX. This is our last question in this episode, and so I want you to pay particular attention before we move on to another part. So M, which is the midpoint of BC, M is the midpoint of BC when you look at the diagram given, and they are saying M is midpoint, and OA is the vector A. So let us now demonstrate this information in the diagram, or illustrate this. When you look at the diagram given, allow me to draw it here. We have it this way, and that way, and then we have it this, and then we have this, and this is our midpoint. This is B, this is C, this is our O, this is our A, and this is our X. The intersection of this point is our X. And we've been given OA is the vector A, and BM or MB is the vector, is denoted by B. Right. So now when you look at that, from the information given, they have said OB is 4OA, meaning in OB there are 4 OAs. Okay? In OB there are 4 OAs. So AB will simply be 3A because we already have one OA. So 3A plus 1A gives us 4OA. I hope you understand that. Right. So now let's look at the first question given. The first question states, express in terms of A and stroke or B, AB, vector AB. They want us to express vector what? AB. How are we going to express vector AB? AB is simply 3OB. 3OB. Because I explained OA is A, and OB is AB, vector AB is simply 3OB. And what are we going to have here? We are going to say AB, vector AB equals 3A. Since, we can even put a footnote there, since OB equals 4OA, as simple as that. I hope you are able to follow from the illustration that is being given there. Question number 6, part B, is on calculus. And most of the times when candidates hear calculus, they are completely put off. I want to assure you that calculus is one of the simplest topics in mathematics, and you just don't need to stress when such questions are asked in ordinary mathematics at this level. It has been included in our new curriculum to prepare you for further mathematics that you are going to do at the university in your first year, those who are going to the School of Engineering and all that stuff. You need a little bit of some calculus for you to operate properly in that field. So they're saying find the equation of the normal to the curve. The curve y equals 5x cubed minus 6x squared plus 2x plus 5 at the point 1 and 2. To find the equation of the normal to this curve, there are certain concepts that you need to understand as a candidate. Here you need to know or understand the rule of differentiation. The rule of differentiation can be simplified in the formula, let's say for example, ax n minus 1. When we are differentiating given functions, the power always reduces by 1. That's why you are seeing the n minus 1 there is appearing. It's different from integration. When you are integrating, the power is gaining. But under differentiation, the power, we are losing a power by 1. You remember what your teachers taught you? Yes, that is exactly what we are going to do. But we'll remind you of this differentiation formula where the power is losing by 1. So now, in order for us to find the equation of the normal to the curve y equals 5x cubed minus 6x squared plus 2x plus 5, we need to differentiate. And differentiating this cubic function means we are simplifying its gradient. In coordinate geometry, at some point you are taught how to find the gradient of a straight line given 2 points. And you are able to say gradient is simply change in y over or divided by the change in x. That has not changed also here. What we are simply doing is we are doing the same thing. Now we need to differentiate. So in this case, we are going to say dy over dx. Now we are what? Finding the change in y divided by the change in x. Okay, let me take you back. If you have 2 and 3, and you have also another point 4 and 5, then they ask you to find the gradient of a straight line passing through these 2 points. You know that this is your x, this is your y, this is your x, this is your y. So now, we have learned that gradient is the change in y divided by the change in x. So that change, in other books they say the difference in the y coordinates divided by the difference in the x coordinates. So what are the y coordinates in the 2 points given? So we have gradient, which is represented by the letter m, equals y2 minus y1, everything over x2 minus x1. You see that? So this is my x1, this is my y1, this is my x2, this is my y2. Right. So now we simply are going to substitute y2 according to the given question is 5 minus y1 3, everything over x2 is 4 and x1 is 2, and then from there 5 minus 3 we have 2 over 4 minus 2 we have 2, 2 into 2 we simply have 1. So this is the gradient of a straight line passing through the points 2 and 3 and 4 and 5. The same concept is used when it comes to finding the gradient of maybe quadratic functions, and in this case we are looking at the cubic function. Right. So I thought I should remind you of that before we go straight into working out the gradient of this given function. So we have dy over dx equals 5 x. When we, okay, let me just write properly the whole given cubic function. Y equals 5x cubed and minus 6x squared plus 2x plus 5, right? So differentiating this, we have learned to say this power 3 will multiply the coefficient here, but it will lose 1. So we're having 3 times 5. This gives me 15x, but minus 1, I'll have 15x squared. You get it? Good. Minus. Again, we'll say this power 2 will multiply this 6, and then I'm going to have 12x. Then 2 minus 1, I will just remain with x. You get it? Now, the differentiation, we have 2x to the power 1. And when this 1 loses 1, we will have x to the power 0. Remember the rules of indices. Any number raised to power 0 is 1. So meaning this 2x to the power 1 minus 1 collapses, it becomes 1. So the differentiation of 2x is the same as what? 1. Get it? Yes. So now we have, this is 1 times the 2 which is given there. We are going to have a 2 there. So x to the power 1 minus 1, x to the power 0 is 1. Then that 1 you multiplied by 2, that's how come you have this 2. Don't confuse yourself there, right? So we move on. This which we have found is the gradient of the cubic function that you've been given. Now, we want to find this gradient at the point 1, 2. So at 1, 2, we are going to replace the value of x in the given gradient for the whole cubic function. Right. So what are we going to have? We are going to say 5, 15. Then where there is x, we replace 1 squared minus 12, then 1, then plus 2. When you expand and simplify everything, you are going to have 15 minus 12 plus 2. And 15 minus 12 gives you 3 plus 2. So you are going to have 3 plus 2. And the gradient of the curve at a point 1, 2 is 5. Remember that the gradient of a straight line at any point is the same, but the gradient of the curve at any point is different. So at 1, 2, the gradient is 5. At 1, 3, the gradient will not be exactly like we have maybe seen. Okay, so now having found the gradient of 5, the question states, find the equation of the normal to the curve. Right. In order for us to find the equation of the normal, we need to find the negative reciprocal of the gradient of the curve at the given point. So what is the given point? 1 and 2. What was the gradient at 1 and 2? It was 5. What is the negative reciprocal of this gradient? It is going to be gradient equals negative 1 over 5. Happy? I'm sure you are happy to see that. Now, we get back to the equation of the straight line. The standard form of the equation of the straight line is given by y minus y1 equals m and then x minus x1. In this case, our m is the negative reciprocal of the gradient of the given function. So we are going to say y minus y1 equals the negative reciprocal of the gradient, then x minus x1. I hope that makes you happy. And when you look at that, what is our negative reciprocal? First of all, we have the point 1 and 2. So I have my y is this, and this is my x. Get it? Good. We have y minus 2 equals the negative reciprocal of negative m. In this case, it's negative 1 over 5. Then x minus our x1 is 1, like that. And if we are to simplify this, we can say, okay, let us multiply throughout by 5. And so we are going to have this and this be eliminated, or it's going to cancel. Then you are going to have 5y minus 10 equals negative x plus 1 after expanding. So after expanding, then you are going to say, we transpose negative 10 to the other side. We have 5y equals negative x plus 1 plus 10. And this gives us 5y equals negative x plus 11, which gives us, if one, two can leave our answer at this level, but we can also say, dividing throughout by 5, we say 5y over 5 equals negative x over 5 plus 11 over 5. This 5 into 5 eliminates. We have y equals negative x over 5 plus 11 over 5. If you want, you can write y equals negative 1 over 5x plus 11 over 5 as the equation of the normal. So that marks the end of our first episode. Catch me later as we move to the second episode and look at section B of the same 2019 paper 2. Thank you. Bye.